Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2019. This is from the topic of electrostatics. This was based on the marking scheme of multiple choice correct. Uh, in my opinion, this question had slight amount of ambiguity which stumbled many good students. But eventually they made an assumption and did this question. So first I'll be telling the solution according to which we are going to get the answer that eventually was given by IIT, and then we will discuss about the ambiguity that I'm talking about. So in this question, what's happening over here, there's a dipole of this dipole moment which is kept on the origin, making an angle of 45 degree with the x or y axis. There's a uniform electric field of magnitude E naught existing in this region. Uh, the potential is constant on this circle. It is given this is a circle of radius r that we draw centered at origin, and the potential is constant on that circle, right? So we have to find, and r is much greater than dipole size, of course. Epsilon naught is the permittivity. So we have to choose the correct options. Like we have to find the value of the radius. We have to comment upon the value of the electric field on different points. So let's see what's like how we will do this question. Now, let's select two special points, A and B. Now, why am I selecting these 2 points? Because we realize that dipole is placed making an angle of 45 degrees. So we know that point A is lying on the axis of the dipole. It's an axial point, and point B is on the equatorial point. That means it's lying on the perpendicular bisector, we can say, of the dipole. Okay. Now, since A and B are both equipotential, so E dot dr, that means net electric field dot dr, this should be 0 at all the points on the circle, including A and B, right? Then only potential will remain constant because we know that dV equals to minus E dot dr. Now, if we want this dot product, now we need to realize that here E is the net electric field. That means the vector sum of electric field produced by the dipole plus the constant electric field that exists in the region. Okay, so at point B, dipole will have an electric field in this direction, and its value will be given by Kp naught upon R cube, right? This is the value of the, let me write it slightly better. So the value of the electric field is Kp naught by R cube in this direction, opposite to the direction of the dipole, right? If you go back and see the dipole moment, the magnitude of the dipole moment is P naught only. Okay, if you take the magnitude of this, so it's P naught, right? So this is the electric field of the dipole, right? Now, electric field can have two perpendicular components. Actually, in reality, it can have three perpendicular components. So this was the ambiguity I'm talking about. I will illustrate more on this very shortly. But as of now, we assume two perpendicular components. So let's say one component is in this direction and the other component is in this direction, right? So since E dot dr must be 0, therefore this component of electric field, let's call this E1 for now and let's call this E2 for now. So E1 must cancel out the field produced by the dipole. Then only we can say that E dot dr will be 0 at this point. Okay, this component will not produce any potential. Only tangential component could have produced some potential. So E1 must have cancelled out this. Hence, we realize that E1 is Kp naught by R cube. Correct? Now, if we apply the same logic here, at this point, the electric field produced by the dipole will be in this direction. Correct? And its value will be 2 Kp naught upon R cube. Okay. Since the external field is of uniform nature, so we will again assume these two components over here. So E1 will be directed in this fashion and E2 will be in this direction. Correct? Now it's pretty easy to realize that E2 has to be 0. Otherwise, the like potential will change at this point. E dot dr can never be 0 at this point because these two components are going to make E dot dr 0. But if E2 persists, then dV will not be 0. So this confirms that E2 must be 0. And hence, the total electric field whose magnitude is actually E naught is actually E1 only. Okay, and its value is nothing but Kp naught upon R cube, right? Now if you go back to the options, the magnitude of the total electric field on any 2 points on the circle will be same. Of course, this is wrong option, as is clearly visible that at point B electric field is 0, but at point A electric field is existing. So of course it is not right. Value of the radius that we have already found. From here you can see that R cube is nothing but Kp naught upon E naught. K co you can write 1 upon 4 pi epsilon naught, and E naught will come like this. So this cube can be written like this, 1 upon 3. Make sense? So this is exactly what is given over here. So option B is correct. If you talk about total electric field at point A, so at point A, if you see, so electric field E2 is 0, E1 is this E naught itself, and whose value already we know that Kp naught by R cube. So E1 plus this. So actually electric field at point A is 3 Kp naught upon R cube, or 3 E naught, we can say 3 E naught, 3 E naught, right? So which does not match, okay? Because if you write that in vector form also, so you will have, you like, it will be I cap by root 2 plus j cap by root 2. So again, it's, you can see it's not matching, okay? Now, which, so this option is wrong. Which option is left? Total electric field at point B is 0, which is correct, because we know that E2 was 0 and E1 has cancelled out this component. So we can say that option D is also right. So B and D were the correct answer according to the IIT key. Now, let's discuss the ambiguity I was talking about in slight detail. If you read the question carefully, an electric dipole with dipole moment this is held fixed at origin in the presence of an uniform electric field of magnitude E naught. If the potential is constant on the circle of radius r centered at origin, then the correct statement is. Now, nowhere they have mentioned that electric field exists in the xy plane only. Electric field can exist, it could have had three mutually perpendicular components. So instead of assuming E1, E2, I could have assumed E1, E2 and E3, and E3 I could have assumed in, like, one direction coming out or coming going inside any one direction. So let's assume E3 coming out, okay? But if you assume like that, then you will not get any option right. Like, none of the options will be correct, because anyway, A and C are anyway wrong. So B, we will not be able to write this equation, because in that case E naught was the total magnitude. So in that case E naught square will be equals to E1 square plus E3 square. Okay, and we will not be able to write this, because even we will not be able to write this part. E1 will anyway be equals to this, but E naught will not be equals to E1, because E naught will be equals to E1 square plus E3 square. So we will not be able to come to this conclusion. Option B, we will not be able to conclude, right? And similarly, electric field and at point B is 0. Of course it's not correct, because E1 will cancel out this component, E2 will be 0, but E3, we are not sure about E3. E3 might persist, because E3 is anyway perpendicular to dr, so it will not create any component, and hence we can say that we will not get any option right. So many students actually face this problem. Many good students face this problem in the exam, and but then eventually they realize that in that case they will not have any option, right? So eventually, the smarter ones assume that electric field must exist in only two dimensions, and then they did this question. But in my opinion, IIT should have mentioned that it's existing only in the plane. That's my take. Thank you.